Hi, my name is Leah Isley. I'm a junior majoring in biology and Hispanic studies with a minor in chem. And I really want to be a Chem ULA because for me, chemistry here started off pretty rough, and I know it's really discouraging, but I really want to help show people that learning chemistry here is possible and that I find it pretty enjoyable, and I really want to spread that love of chemistry to other people. And something that's really helped me get to that point in my relationship with learning chemistry has been the weekly ULA sessions, where I feel like it's a community where you can get together with friends and talk about problems, ask the ULAs for help. The ULA session I go to for Ergo 2, they bring us candy every week, and it just feels really relaxed and kind of, you're learning chemistry in a more digestible way, which makes it feel more approachable and like everybody can do it. And I really want to help give back to that community because it's truly helped me grow so much as a student, and I really enjoy it. And some advice I would give to students in chem would be to do weekly one pages. This is something I've started doing this semester, and it's every week I look at the slides and I write down all the big concepts that we did in lecture. And if there's anything I don't understand, I clear that up then, and I do the practice problems in the slides again as a review during this time, and then I do the end week after. And that's my way of holding myself accountable to keep up with the content on a weekly basis, which is helping me go into the next week with a fresh mind and feel more confident that I know kind of everything else that we've talked about. And I also annotate these every week to keep up with the content, and that's made it a lot easier to study for exams and a lot less daunting. And another resource would be Robin Blanton at the Learning Center. She's a great academic coach, and she's helped me change my study habits and figure out what works best for me, and she's super helpful. So to start this, we're going to be doing a mechanism from exam 2. We're going to shorthand this ring right here, these two substituents using R groups. So we know this molecule right here isn't going to be the most reactive. And you know there's no formal charge driving the reaction, and so that it's in acidic conditions, we know we're going to want to start by protonating something, which we're going to do by protonating this oxygen right here. These lone pairs are going to grab a hydrogen from this hydronium, and that's going to protonate that oxygen. What that does is make this molecule a lot more reactive. It's going to drive this reaction to occur quite quickly, and something that happens quickly are intramolecular reactions. If something can happen within the molecule itself, it's going to do that first. So we have this extra lone pair from this oxygen here. We're going to push it in and pop this ring open. Something that really helps me when I'm doing these sorts of problems is knowing my end goal. Looking at this top hat structure up in this top right, I can see that we're already kind of halfway there with this ring opening. We know we have this half of the molecule good, but over here we only have one oxygen and we want to get to 2. We know because of this step there's going to be water floating around in solution, and we have this activated carbonyl with this oxygen right here. So what's going to happen is the lone pairs on the oxygen are going to attack this activated carbonyl, because this is going to be super reactive. What that does is it breaks that positive on the carbonyl, and it makes this group right here with another positively charged oxygen. This top group stays the same, and this no longer has positive charge. So now that we know that there's water still in the solution, proton transfers happen super fast. And we know that this group doesn't want to have a positive charge anymore. The fastest thing that will happen is one of these hydrogens gonna get removed by that water right there. That'll reform hydronium. Now, we have a neutral molecule. What's going to happen now is, again, we look at our final products and we're going to see one of these groups needs to get popped off because we want to recreate this carbonyl right here. This bond's super stable. We always want to try to keep the CO bond. How to do that is to make this top hat. What are we missing from that? We're missing a hydrogen. We're in acidic conditions. We have a lot of those. We're going to protonate that, take a hydrogen off from here. That oxygen is protonated. Now, that oxygen is going to be super reactive. What can it react with? Intramolecular again. This is going to drive in, pop that right off. Positive charge. Now, that top hat is fully created. We're done with that. That product is made. Now what we're left with, that's messy, that's okay, is this group. All we need to do is an acid-base reaction to deprotonate this carbonyl. That's going to be done with the water that's still in solution. Just take that right off. Now we're going to rewrite this instead of R. Sorry, this angle is so bad. And that way you have your final product, and then you have that top hat over here. And that's it.